When you think Heathkit stereo, you might visualize something like this. But did you know they also had components like these? Introduced in 1978, Heathkit's Pro Series components were all rack mount compatible, and by 1982 the series included the AJ1600 tuner with Dolby FM noise reduction, the AP1800 preamplifier, the AD-1703 equalizer, the AE-1705 EIA standard rack, the AD-1706 active audio processor, the AD-1702 variable electronic crossover, the AD-1701 graphic output indicator, the AA-1600 125 watt per channel amplifier, and the mammoth 250 watt per channel AA-1800 amplifier. Surprisingly, the high-end Pro Series components were introduced around the time Heathkit was purchased by Zenith, a company that was far more interested in Heath's computers than audio kits. Still, the Pro Series stuck around for a while. But by 1986, about 7 years after the Pro Series was introduced, Heathkit stopped offering stereo kits in their catalogs altogether. They came back briefly in the 1988 catalog, but these were components developed by Harman Kardon and not true Heathkits. By 1990, these disappeared also, and by 1992, Heathkit stopped kit production entirely. When they were around, Heathkit promised that in performance, specifications, and sound reproduction, the Pro Series components would rank with the finest stereo components available anywhere. Stereo Review backed this up in their September 1980 issue, where they said the Pro Series AP1800 preamplifier does practically everything one could want and does it to perfection. They said the kit's assembly manual was very complete and informative, and that the AP1800 has a handsome professional appearance, and the finished kit could not be distinguished from a good quality, factory-assembled product, and gave no external clues to its origins as a box of parts. 40 years later, I managed to find a similar box of parts when I bought this unbuilt AP1800 kit on eBay. In this series, we'll build the kit and test its performance when complete. Today, there are few opportunities to build stereos from kits, so it's always a treat to find an unbuilt vintage kit. Some may feel these kits should be left unbuilt for history's sake, but I just can't resist. Besides, by producing this series, the videos will document and share the fun of these kits with many that might otherwise never get a chance. Let's begin. Okay, let's open up the box and see what we've got. Typically very detailed Heathkit manual. Looks good. Important notice, dear customer, we are in the process of changing the standardization of screws from slotted head to Phillips head. Interesting. The new screws will also be black or stainless steel instead of zinc. Okay, so we may have a combination of Phillips and slotted in this. We'll see. Apparently there's a magnifying glass supplied as well. Interesting. Okay, set that aside. Set the manual aside. This is our big illustration booklet. This will come in handy. Excellent detailed drawings. Great to have. This looks like the schematic. Yep. Excellent. Fantastic. Big, clear, easy to see. Okay, we've got four rods and a, it looks like one of those cheap RCA cables. The ends are pretty generic, but the cable itself is pretty weighted. This is probably some good quality cable in there. Some foam tape, which is disintegrated. It's almost as bad as the foam I removed from that Macintosh MC2105. This is a little bit younger, so this one's about halfway there. And let's see, do not unpack until the manual calls for each pack by number. All right, well, I think in our case, though, given how old this is, I am going to unpack everything because I do want to do an inventory, and also I want to check all of the components before we use them. This appears to be a pack of wires. Ah, these are the for the front panel, for the rack mount handle. And the other. And this looks like miscellaneous semiconductors. Or, actually no, these are the speaker jacks. And yeah, it's kind of interesting. You wouldn't really necessarily expect speaker jacks in a preamplifier, but this one does things a little bit differently. Yeah, looks like, are there any capacitors in there? Looks like just some ceramics. Those are going to be fine, so maybe I'll set this back aside. I want to test those. Okay. Shielded air ports for the chassis, and let's see. This could be a choke or a coil, or oh, maybe just knobs. These are the knobs. Yeah, those are the knobs. Looks like they're all there. Good. Ah, okay. Looks like, just gonna jump right to this because I'm just noticing it. A little bit of corrosion in the chassis. Looks like some moisture got in there. Not a big deal. It's not really an exposed area. Certainly not going to see it. So hopefully all the exterior metal is in good shape. But this we can clean off a little bit. Not a big deal. This bundle was what? Ooh, is it a transformer? Yeah. And yeah, a bit of rust on there as well. That's a shame. So yeah, apparently this was, looks like the box is in good shape. It didn't get any direct moisture, but it must have been in a humid area. Again, not a big deal. We can take the rust off of that very easily. Certainly hasn't seemed to have done any damage to the transformer. There's some miscellaneous chassis parts. Cover for one of the transformers, I guess. Not sure. And what's this? This is like some old newspaper in here. Fortune cookie says, beautiful relay. And yeah, interestingly, it looks like moisture didn't get to this, so that looks great. Perfect. What's this paper here? So, not newspaper at all. It's just actually the warranty for the relay. Some wire. More chassis parts. This one's in pretty good shape. And you can see we've got some PC boards down at the bottom. Let's deal with this first. Parts 2 of 2. These are... Boy, it does look like everything's here, though. Looks like we have resistors, 1 of 4, resistors, and some diodes, and resistors. These are likely to be fine, but I will test a few of them, just to make sure. And... let's see. Not sure what's in these. Okay, yeah, here we have a bunch of more resistors and some electrolytic capacitors. So this device, let's see, this goes back to the late 70s, early 80s. So yeah, we definitely need to check these electrolytics. Some of these may need to be replaced. They look good, but does not mean that they're not leaking electrically. So that'll be one of the first things we do, is to test all these semiconductors. Okay, and these are going to be more switches. Nice. nice. Looks like some nice nylon bushings in there. Everything is moving beautifully. Again, though, and here's with some dual gang pots with a center detent. So these look great, but they're definitely going to need to be cleaned because most likely these are going to be dirty. So we'll need to clean these out very carefully. So we want to do that before we install them and test those as well. So I'll set those aside here. For lunch today we have nice. Interesting, beautiful switches, toggle switches. It's like a crane. Okay, yeah. And some more dual gang controls. These have detents at every position. Very nice. Okay, more wire. There's a lot of these quick connectors. Beautifully finished. And lots and lots of PC boards. Let's just take a quick look at the trace on these, see what kind of quality we have. Yeah, these look to be a very good construction. These foils are unlikely to lift when we apply heat to them, so these are excellent. Should have good luck with those. Lots of PC boards. I've got my work cut out for me. Yes, it's a very complicated circuit. And another very large PC board. Beautiful though, just so nice. Yeah, these will be a joy to work on. More parts. And more electrolytics. And what else? Looks like I see some coils, more electrolytics, some posts, some mylar capacitors. Are these lamp holders? What's that? No, it's another toggle switch with some type of strange ceramic back. Probably the power switch. Yeah, built for heavy duty use. That's nice. I think that's what that is. And what's that? Fuse holder. Look at this beautiful little wrench we got with this. Nice. And let's see. These look good. Need to be cleaned up a little bit. Not too bad. I won't be upgrading these. I'm going to be using what came with the kit. No expensive gold RCA jacks are going to go into this. These are more than good enough. Okay. Accessory outlet. And just 2-wire. So interesting. I wonder if this is this just a 2-wire non-grounded circuit? Probably is. Late 70s. Before a lot of things went to 3-wire. Lots of beautiful solder. That's the good stuff. That ain't lead free. Ah, here we go. Yeah. 2-prong. Non-grounded. There's the big electrolytics. These are Nishikans. Wow, look at that. Very, very nice. It'll be interesting to test these. Be a shame if we can't use these. Yeah, these are very nice, high quality capacitors there. Boy, Heathkit didn't skimp. I'm surprised to see those Nishikans in there. But this is the Pro line of Heathkit, and yeah, they were really trying to compete with the, with the big boys, with the certainly the Sensuis and the Marantzes and the Pioneers and the Techniques, and even to a certain extent with Macintosh. It's supposedly a very high quality preamp with a lot of interesting features. We'll see. Yeah, more Nishikans. Very nice. And so we've got I forget what these are for. They look like alignment tools, but I think I had another Heathkit kit when these were used to insert some hard to access screws. I forget what, but we have it. Okay, not sure what that'll be used for. But, yeah. More miscellaneous parts we'll need to test. Wow. Wow, this thing has a lot of controls. Yeah, what is that? A push button? No, that's... Wait a sec. That's like a... What kind of control is that? I'll pop that open. Looks like a fader, but it's not. It's actually... It's got like a ratchet system on it. Interesting. Okay. Looks like a multi-position switch, actually, but it's done in a sort of a different style than I've seen. Interesting. Okay. Again, look like really high-quality components were used. There's the magnifying glass. Goodness knows I can use that these days. And another, look at that. Beautiful, beautiful. Everything is enclosed. Wow, very good quality. Switch. Very interesting, difficult to clean, but yeah, that's a nice quality switch. Nothing is open, nothing's exposed. Everything is, all of these plates are covered in this plastic. Superb. And more cool looking switches that I'm not used to seeing with Heathkit products, that's for sure. Sort of exotic. Okay, those tantalum capacitors and some, let's see, now we're getting into some transistors or SCRs here. Yeah. Yep. And some various capacitors as well. These are the first transistors I've seen. Didn't see any ICs either. Everything is discrete, apparently. Okay. A little pitting. Again, not bad at all. Okay, here's the back panel. Gonna keep this in the plastic for now, just to protect it. This looks good. I don't see, thank goodness, any rust here. And the paint, everything looks fantastic. Great. Let's hope the front panel is in a similar condition. Ah, that must be in here. Let's see what we've got. Crossing our fingers. Certainly looks like I'm the first person to open this in a long time. Okay, here we go. Here's the reveal. Wow. Yeah, you're not gonna find one of these on eBay with a faceplate like that. Look at that. Absolutely perfect. Gorgeous, gorgeous. You can see what an interesting preamp this is. I haven't really spent too much time looking at it, but we have all these cutoff filters for the tone controls, which is very interesting. That would give us sort of a parametric sort of type of equalization capability. A lot of choices for the capacitance for cartridges. The adapter, I think this was for adding like an equalizer or something like that instead of using the tape monitor. We'll find out together. These nice stereo features, left or right, stereo, left and right, left minus right, and reverse stereo, very nice. I have these types of controls on a lot of Macintosh equipment, and it actually comes in very handy. And volume, interesting, the volume is denoted in decibels. And the muting, 2 levels of muting, 20 decibels or 40, interesting, don't think I've ever seen that before. And let's see, loudness, okay, so we have a variable loudness here, and interesting, if we turn it all the way up, it's flat. I would have thought the other way, but we'll have to see how that works. Some good recording, record monitor and tape path controls as well. Excellent. Okay, and oh, we do have a, this has a phone output too, so we do have some basic amplification here too. So this could be used as a headphone amplifier, also very nice. Great. All right, I'm gonna put this away. We won't be needing this for a while. Hey, this is kind of fun. I'm getting excited to work on this. And what do we have here? Appears to be an adhesive piece of cardboard. Interesting. Probably maybe used for isolation between a component and the chassis. Not sure. We'll find out. And another similar type of adhesive cardboard paper. Not sure what that's used for yet. We will find out. And let's see. Now this would be the top cover. It's interesting here. I don't know if you can see this, but the dust is sort of in the form of the PC boards that were laying on top of it. I didn't notice any corrosion on the PC boards, but I will have to double check that because this is sort of indicative that something was going on one of them. I'll double check that later. I don't think so though. I don't recall seeing any problems, but I didn't look that closely either. Alright, let's remove this and our top cover. Here's hoping this is in good shape too. I don't really want to be painting this or removing rust, so let's see. This was on the very bottom of the box, so one would expect this to have perhaps had the most potential to be exposed to moisture, so let's verify that we're in good shape here. Looks like this is actually a separate piece. This would probably be our bottom panel. And yeah, we'll need to clean that up a little bit. Nothing major. Looks like it's symmetrical, so we can make this the outside. And looks pretty good so far. Looks good from the inside. Looks good. Yeah, very nice. Perfect. So far, let's see this side. Yeah, looks great. Excellent. Very, very nice finish. This is good because I didn't want to have to paint this. This unit can be rack mounted, and there was also an optional cabinet, wood cabinet. I'm not sure what I'm going to do with this, but if I don't put it in a cabinet or rack mounted, it's good to know that this outside is in such great shape. Great. Okay, I'm going to go through this a little more carefully now. I'm going to organize everything. And then I'm going to prepare the parts that we need to test. Okay, I've organized all the parts and I've been going through the electrolytic capacitors. Boy, I gotta say, I'm impressed. These 40-year-old Nishikons that were included with the kit are still performing as new. Let me just test a couple for you so you can see what I mean. Let's start with this 6,000 microfarad 16-volt electrolytic. This one's marked a little bit differently. You'll see the arrow is pointing towards positive, whereas with most electrolytics, the arrow points towards negative, as you can see on this other capacitor that was included with the kit, arrow pointing towards negative. Okay, so be mindful of that. Let's just hook this up to our tester real quick. Positive, negative. And let's test this one to 16 volts. Now, the tester only goes up to 15, so we'll stop at 15. Whoops, I should have been in discharge, but I wasn't. Fortunately, I had the voltage down to 3 volts, so that's all that was going through those leads. Do be careful with these testers. So we're going to start in discharge. I'm going to put it now into the leakage position. We have electrolytic selected. We're at 3 volts. Let's bring it up to 15 and take a look at the magic eye. That triangular black window at the bottom there, if that closes and does not open, that indicates DC leakage. Okay, so 3 volts. 6 volts, no leakage, 10 volts, 15 volts. Now you might have noticed that the window closed a little bit, but a new capacitor will test the same. So again, this capacitor is testing as new. Let's try another. Discharge, turn our voltage down. Now let's test this 10 microfarad capacitor, which is rated for 80 volts. Negative. And our positive. Set that aside there. Okay, leakage, 3, 6. We're going to go up to, we'll go up to 50. Maybe spend a little bit of time at 100. This electrolytic is rated for 80, so we're kind of in between the two. All right, 6, 10, 15, no leakage, 25, 50, no leakage. Very quickly, let's go to 100 just to see. And does it open? Yes, and it does open even at 100. So again, this capacitor is performing as new. 40-year-old Nichicon electrolytic performing as new. And let's just test one more. This is a 470 microfarad at 63 volts. And the tester has positions only at 50 and 100, so we'll just go up to 50 on this one. Leakage, okay, 3 volts. Take a look at the eye. 6, 10, 15, 25, 50. Does it open? Just need to charge up. It's not uncommon. Even a new capacitor will take a little time to charge up. And as you can see, no leakage. Another 40-year-old Nichicon electrolytic capacitor performing as new. That's good quality. Okay, so these 40-year-old electrolytic capacitors made by Nichicon and provided with our kit are clearly all testing as new. And there's no need to replace these with new capacitors, right? Well, I'm sure for many of you out there that would be a definite yes, but for me, I'm going to have to say no. And here's why. I actually have been pulling my hair out over this one. It's been a tough decision. But these are 40-year-old capacitors. They are performing well now. They are of superb quality. But what about 10 years from now, 20 years from now, 30 years from now? For peace of mind, I am not going to use the capacitors that came with the kit, again, even though they are performing perfectly, because I just want the peace of mind to know that this preamplifier, when we're done, is going to be good for another 40 years without having to worry about opening it up and replacing capacitors. If I use these old capacitors, I'm just not going to be able to shake the feeling that they're a ticking time bomb. Now again, I know this decision is probably a little bit controversial for some of you, and many of you will disagree. And that's just fine. Repairing vintage electronics is sometimes not just science, but it's art. And what works for you may not work for me. With my projects, I take a money is no issue approach. So I'm willing to spend a little bit more for peace of mind. If for you that sounds wasteful and you'd rather wait for something to happen and then diagnose the problem and replace the capacitors when they actually do show some problems, then I completely understand and would also support your decision. Fortunately, I do have a lot of the capacitors necessary already in stock to do this project, but yes, I did have to order many more. And note that this is only a tiny fraction of the electrolytics used in this project. Before we move on, I just wanted to review how to check for the date on these old capacitors. Here's that Nichicon 6000 microfarad, 16 volts that I showed you earlier. Let's turn it around and you can see a number there, 25-272. Probably not a date code. Let's keep looking. Here we have N8134. That is indicating that this capacitor is from 1981 and was made on the 34th week of 1981. Okay, let's try another. This one says H8216. Okay, so most likely this was manufactured on the 16th week of 1982. This one that was included with the kit is actually not a Nichicon, but I believe that says Mara. And let's turn it over here and we can see that the date code looks to be 8212, again, the 12th week of 1982. So this is helpful. I wasn't sure exactly when our particular Heathkit preamplifier kit was made, so ours apparently was made sometime in 1982. Good to know. Let's move on. This looks a little bit like a mad experiment, but it's actually pretty simple. Very quickly, I just want to test the transformer that was included with the kit, just to make sure there are no problems. This transformer seems pretty generic, but sometimes replacement transformers can be difficult to find. So before we get too deep into building this kit, let's make sure ours is working correctly. The primary of this transformer can be wired for 120 volts or 240. I've got it wired for 120 volts. It's connected to our variac and will increase the voltage slowly to 120 volts. I've also connected this old Heathkit line voltage monitor so we can see the voltage on this display. And between the variac and the transformer, I have a 100-watt light bulb which will serve as a current limiter, just in case there's a short in the transformer or I screwed up the wiring. And on this terminal strip, I've hooked up the various wires coming from the secondary of the transformer. Between this point and this point, there should be about 76 volts AC, and between either this point or this point in the center, it should be about half of that. And between these 2 points, we should have about 12 volts AC. The voltages will probably read a bit higher as there's no load connected to the transformer. I'll use my Fluke multimeter to check the output voltages, and you can see those on this display. Let's start with the variac at 0 volts. Let's turn that on, and let's turn on our current limiter. And I will slowly turn up the volts, watching here for any problems, and also here to monitor our voltage. Let's begin. No problems seen so far. Okay, we're now at about 95 volts. No issues. Go a little bit further. 100 volts. 110. 115. And let's go to about 120. Okay, now let's test the output from the transformer. As I said, between these 2 points, we should have about 80 volts. 87.3. Again, there's no load on this transformer, so that's fine. And between here, we should have half that. Perfect. And between these 2 terminals, we're looking for 12 volts AC. And at 14.22, given that there's no load, that's perfectly fine. So good news, our transformer is a little bit rusty, but working just great. Let's now test a few of the controls that came with our kit, just to make sure they're operating correctly and to see if they need to be cleaned or not. This is a 100K potentiometer with 2 gangs. Let's hook it up to our ohm meter and see how it's performing. Let's try the bottom gang first. Now, as I turn this up, what we're looking for is a very smooth action of the meter needle. If it bounces around, that indicates that we have some problems with the potentiometer, and it most likely needs to be cleaned. We're also testing for resistance, and I have the scale set so that at 100, it will indicate 100K ohms, which is what we're looking for. And you can see that at the 0 position, it's pretty much at 0 ohms, which is what we want. I'm going to turn the shaft clockwise now. Let's see what we have. Okay, so far very smooth. No indications of any intermittent problems. I'm going to turn it all the way up now, and let's see if it reaches the 100K ohm position. There we go, perfect. I'm going to go back down now, and let's see how smooth it is. Wonderful, absolutely perfect. These 40-year-old potentiometers are clearly of a very high quality, and even though they've been sitting in that box all these years, they're operating as new. We tested this gang. Now let's test this one. Let's move the clips here. I'm going to turn it back down all the way again. And let's see. Right about 0. Very good. Let's turn it all the way up. Very smooth. Very nice. Look at that. Beautiful. I'm not going to need to use any deoxit in these potentiometers at all if they all test like this. Great. All right, let's try another one now. This is another 100K ohm potentiometer, and this one has just 1 gang. Okay, when I go to the first detented position as I turn it clockwise, it goes right up to 100 ohms. Let's go all the way. About 200. The next detent, a little over 300. Under 500, the next detent, all the way, all the way, all the way, and it does go to 100K ohms. Let's go back down again. Yeah, and we do have that big jump. Okay, I see. This potentiometer is not designed to have a logarithmic or audio type taper. It's a linear, and we can see that because it's indicated by this L and also by the behavior. This is another linear taper at 100K ohms. Let's see if this one behaves the same way. Let's try this side first. Okay, all the way down, and yep, big jump from 0 to 100 ohms. So again, this is a linear taper, and it's, yeah, you can see how watch the first turn, big jump, second turn, a lesser jump, and then the third, an even lesser jump, and an even lesser jump, and an even lesser jump as I go up. So that's a linear scale. Let's try the other side. And this will work the opposite way. We'll have 100K ohms at the fully counterclockwise position. Let's turn it up, and we'll go back down. And you can see, again, with every turn, the jump is that much greater. Okay, but very smooth. Again, no intermittent problems. Okay, I've only tested these 3 potentiometers, but I think it's safe to move on, and we don't need to test every control at this point before we begin. Instead, as we build the kit, we'll just test each individual control before we install it to verify that it's functioning properly. To complete our testing before we build our kit, let's just test a couple of random transistors and resistors to see how they're doing. I have 2 peak meters here, an LCR and impedance meter. We'll use that to test some resistors, and the AE-1705 semiconductor tester, and we'll use this to test our transistors. Let's first test this brown, black, orange, gold resistor. This is 10K at plus or minus 5% tolerance. Let's turn on our tester. And again, we're looking for 10K, and we have 9.93 or so. Perfect. Now let's test a blue, gray, orange, gold. This should measure 68K plus or minus 5%. And we have, yeah, dead on, 68K. Perfect. And now I have a, let's see, a brown, red, brown, gold. This will be a 120 ohm resistor. Again, plus or minus 5%, which is denoted by the gold band, the last band. And we have, look at that, 120, right on the money. Yeah. These resistors in this kit, they're, of the vintage where we're unlikely to have any problems, so they're obviously testing just fine. I might test a few more as I install them, but looks like we don't need to batch test any of these. They're in good shape. Now let's test a couple of random transistors to see how they're performing. This first one should read as an NPN bipolar junction. Let's connect our leads. Blue, the green, and the red. And with this tester, it doesn't matter which color goes where, the device will auto-detect. Let's turn our tester on, and we're looking for an NPN. Great, NPN. No indication of any shorts, and we can see that the tester is telling us that the red lead is now connected to the emitter, the green is connected to the base, and the blue is connected to the collector. Let's try another one. The last transistor was an NPN. This one's a PNP, so let's see how it tests. There we go, PNP, silicon BJT. No indication of any shorts, seems to be working just fine. The red is connected to our base, the green to the emitter, and the blue to the collector. As I said with the resistors, these transistors are likely to be fairly reliable. There shouldn't be any issues with them. But as we progress through building the kit, I may randomly test a few just to make sure they're okay. But no need to batch test these transistors, as they're likely to be just fine, and we can start building our kit now. That wraps up part 1 of the Heathkit AP1800 series. Stay tuned for part 2. To stay updated, subscribe and click the bell. And if you like this video, please give it a thumbs up. See you soon.